Let's have a look at linear inequalities, and this is grade 10 level. First, you need to understand that between linear inequalities and linear equations, really, there isn't much except the fact that the other one has an equal sign and would provide one solution if there is a solution to the equation, and the other has many solutions. A range of them, they could go up to infinity depending on the answer that you're getting in the inequality. Get an equation of 2x minus 3 is equal to 9 versus an inequality of 2x minus 3 is greater than 9. The other one is looking for a value that will make the left-hand side equal to the right-hand side. That is your equation. The other one is looking for a value that would make the left-hand side greater than the right-hand side. So that's where the difference is. The solving is similar. You still use your knowledge of solving equations in your inequalities. As you can see that you've got similar things. But at the end, the solution in equations would have been saying the value is equal to 6. But here, the value is greater than 6, meaning any value of x that we can put in there that is greater than 6 would balance our inequality, where the left-hand side would be greater than the right-hand side, because those are basics. Okay, so this one would be true for all values of x greater than 6, and it excludes 6. But look at this one, where now there's an equal sign on our inequality sign. The answer says x is greater or equal to 6 and equal to 6. And in this case, it means the values of x that would balance our inequality start from 6. It's very important to understand that. The question, though, is something that is crucial and important in inequalities, where your negative sign, if you divide both sides by negative sign or multiply by negative sign, the inequality sign will change direction. I just want to illustrate that. Let's look at a very simple thing here. 12 is greater than 5. That is very, very clear. But what happens when we multiply both sides by negative? And do we still have exact same true inequality that negative 12 is greater than negative 5? That is not true. So what then happens is that during any division or multiplication of both sides by a negative sign, you would have to change the direction of your inequality so it becomes true. And in this case, negative 12 indeed is less than negative 5. That's very important. You need to remember whenever you get to inequalities where you have to divide or multiply both sides by negative. Here's another one, just in an equation situation. And now we divide both sides by negative 2. Look at what happens in our answer. Our answer, x is less or equal to negative 3. Okay, very important to remember that. Now, let's look at some examples. Sometimes you might be asked to represent a solution on a number line. There's an equation, equation 1 and inequality 1 and 2 there, where you can solve. But what I wanted to really highlight here is sometimes you get told what values of x, meaning the set of numbers that you're looking at in terms of your inequality. So the x refers to a set of numbers that is real numbers. So by the time we solve our equation and we have to represent it on a number line, we know in mind that we're representing real numbers, meaning all numbers. On the other side, we're being asked to solve an inequality where the value of x represents integers. Now you'll remember integers, those are the numbers we use to write the number line. So when we draw the number line, we actually use integers, so there are no decimals. So our solution therefore is referring only to integer numbers that are greater and equal to 6. But here we're referring to all real numbers that are greater than 6. On the number line, as a result, when we represent our real numbers, look at our representation. We don't include the 6, but then we cover all, because there are decimals between 6 and 7, between all the integer numbers. So our arrow must show that we're covering all those numbers greater than 6. But look at this other one where we have integers. We really literally have to pick the integers there. But now since they go up to infinity, there's no way we can finish that. So we then use this type of an arrow to show that we are skipping any decimals and we are covering only the integers. You will do the same thing with natural numbers. You'll do the same thing with whole numbers because they don't include any decimals. So always remember that when you represent your solution on a number line. Here's another example of a double-sided inequality. Solve. Remember, still do the same thing. Additive inverse of negative 2 on both sides. Then you divide both sides by negative 3 and look at the inequality signs. When you get one like this, just make sure that you fix your answer, because normally when we write with inequality notation, The lowest value is on the left side and the biggest value is on the right side. And we read it from the middle. Please don't do that thing that other people are saying, -5 is less than x. No, there's no such thing. It's the values of x we're talking about are greater than -5 and less or equal to -3. So make sure that you get an idea of what you're talking about there. And that will be good enough. When we represent that on a number line, look at that. We don't even need to be showing other numbers. We can just show the main important numbers. -5 is not included because there was no equal sign on the inequality, but -3 is included, and we show that with a shaded dot. Okay. Here's another one, but this time around, same equation or similar equation, but we're talking about integers. How would you represent these now? Similarly, when you divide both sides by a negative, and your inequality sign changes direction, and then fix it and write it correctly. -6 is smaller than -3, so that must be on the left. So our values that we need to represent are greater than -6 and or less or equal to -3. But they are integers, so let's pick integers that are greater than 6. The first integer greater than 6 is -5, and the next one is -4, but obviously we know that the last one would have to be -3 because we said they must be less or equal to -3, and those are the only solutions to that inequality. Okay, let's look at other examples. You can get some that have fractions but doesn't change anything in terms of your solving of inequalities. Similarly to equations, multiply both sides in this case and then you get that. But remember, we're dealing with natural numbers, so when we represent on a number line, we need to keep that in mind. Eventually our answer is x is less or equal to 3. So on the number line, we only need to represent the solutions that apply to the inequality solution. It's those that start from -3 and they go all the way down. But these are natural numbers. There are no other natural numbers below 1. Remember, natural numbers start at 1 and they go up to infinity. So if we are representing the ones that are from 3 going down, the last one will be 1. So watch out for things like that, tricky scenarios. And here we're representing whole numbers similarly on a similar equation, sort of inequality. And again, we need to represent natural numbers. But look at this one. Because natural numbers start at 0, we are now able to go all the way up to 0. But there are no whole numbers. Sorry, there are no whole numbers that are less than 0. So those that are less or equal to 3, they start at 3 and they go up to 0. And that's it. Those are the only values that are relevant to that inequality of whole numbers. Again, let's look at this. Those that would end up giving you a solution that goes up to infinity. So our solution here says x is greater than -4. That means they go all the way up to infinity. How would you represent those? Again, the first natural number that is greater than 84 is 1. And then you can put a few and then show with an arrow that you are skipping, just like we do with integers, and you are skipping all the decimals. Again, here you will do the same thing with the whole numbers. Again, we have to represent those that are greater than -2, but here again the first whole number is 0, and then pick a few and then show with an arrow that it goes up to infinity. Can you see? So it's very important to look at the type of numbers you're representing. They will then in turn determine to you what numbers on how you need to show that on a number. Right, let's look again at something else, notations that we use within our inequalities. Now remember, this is just about representing a set of numbers, and in this case, if you look at this, this is when you would have listed the actual numbers that belong to that set. Now there are obviously shorter ways of representing that. There's set beta notation, sometimes called inequality notation. There's interval notation, and there's number line. So you've already seen two of these. The only one you haven't seen is the interval notation, and I just want to quickly show the comparison between the three. Here's an example. A set of numbers that are greater than -1, but those numbers are integers. We cannot represent those numbers on interval notation because your interval notation says from -1 to this number or from 2 to this number. So as a result, you then are including the decimals in between your integers. So we cannot use interval notation there. But on the number line, you've already seen this, we've done, and we represent our integers with ease. The second example is natural numbers. Similarly, no interval notation there, but on the number line we can represent them. Is those numbers greater and equal to 2 or equal to 2 that you're representing, they go all the way up to infinity. Okay, but now in number 3 we are represent real numbers, which now suits interval notation because we're covering all numbers in between the integers that are real numbers. Remember, you've got fractions there, whether they are rational or irrational between your integers. So those are being represented, and in this case we want to represent numbers that are greater than -3 and or less or equal to 7. Now take note, in the notation itself, similarly to your set beta notation, the lowest value is on the left and the biggest value is on the right. And that's basically all that happens in all notations, because we're trying to represent what is happening on the number line. So on the number line, your smallest values are on the left, the bigger values are on the right. And similarly, then we do the same thing on our notations. And on the number line, obviously, we will not include -3 because it's not been included. We can see it in the cell notation, there's no equal sign. We can see it in the interval notation, it's an open bracket. And when we use a closed bracket like that, then we would use a shaded dot in our representation, which is what we do on 7. Okay. Let's look again at the 3 notations. This time around, example 4, x is an element is less than or equal to 3, but it's an element of real numbers. Again, interval notation here works. But now take note, because the numbers are starting from 3 going all the way up to -infinity, you would have to use -infinity in your interval notation, but there is no way -infinity and positive infinity can be included. So we cannot use a closed bracket, because really, what number would you call infinity or -infinity? So at what stage do you say this is the number, this is where we stop? So we simply put an open bracket and we put -infinity or infinity. But 3, we use a closed bracket because that's where we're starting with our real numbers. And similarly on the number line, shaded dot and all the way to -infinity. So watch out there for your interval notation. It's quite technical. You want to make sure when you use it that you represent things correctly. And here's another example, x is greater than 8, and this one uses positive infinity because it's numbers that are greater than 8, but they go all the way up to infinity. And again, because whatever is on the right on the number line is bigger than what's on the left. So 8 is on the left and infinity is on the right there. And again, we'd show that on our number line with an open dot because we don't include 8, but we use an arrow that goes directly all the way to infinity because we're including every decimal that is there. Okay.